Hey, Jody here, weldingtipsandtricks.com. I've got Andrew Carden here with me today. Let's hit the booth.
That's right, let's hit it.
First off, a special thanks to Triangle Engineering for supplying the test plates for this video. This is a very standard test, 22.5 degree bevel plates, 3/8 inch thick, 1/4 inch back end plate, 1/4 inch gap. It's right out of the American Welding Society D1.1 structural welding code. Now, I was going to let Andrew talk you through this here on his advice on how to position the piece and how to hold the gun, but there was so much background noise, didn't bring my lav mic with me, etc. So, height is very important. Just because it's overhead doesn't mean it has to be over your head. Just got to be somewhere where you can be comfortable and get a good line of sight on it. So, you want to practice how to hold the gun, what works best for you. There's no hard and fast method there. You can turn it out sideways like this and run the trigger with your index finger if that works better for you. And the only way to find out is just do a bunch of dry runs like this. Just figure out what works better for you, how you can make the run without getting hung up. You'd prefer not to make any tie-ins here, but there are some codes and some test shops that will require you to make at least one tie-in somewhere in the middle of the joint, so be prepared for that. Follow the WPS, that's the Welding Procedure Specification. Line of sight, super important. Usually you want to get off to a little bit of an angle so that you can see both sides of the puddle and the leading edge of the puddle, and so that your nozzle is not blocking the puddle at all. Again, just kind of do some dry runs, figure that out before you hit that trigger. Everything changes when you drop the hood. We're using a Lincoln PowerMig 350 MP today, around 25 volts, 360 inches a minute with 045 Lincoln Ultra Core 71A85 wire. Now, there is some leeway on the voltage and wire feed speed, but you pretty much can run overhead almost as hot as you can run flat. You certainly don't want to turn it down cold just because it's overhead, because as long as you hold the right stick out, you get that arc force punching in there, it drives in there and it flattens out. You use the arc force to help the bead flatten out. Andrew is just using a little slight wiggle here for the root pass. You want to really punch into that back end strap and make sure you don't have any voids or anything like that. And everything has been cleaned. No mill scale on anywhere where the weld is going to penetrate. Here's another view. I'm trying to give as many looks from as many different angles as I can of this. All right, well, that's the first pass, and it came out pretty darn good. What you want is a nice flat surface so that now you can stack two beads over top of that without having any creases or little valleys to try to penetrate in. It'll penetrate easily. You don't want to trap yourself in little corners. You may not be allowed to use a grinder on this test. In fact, it's highly likely that you won't be able to use a grinder except for the cleaning. So the first bead is stacking in there, just barely coming out to the edge, trying to leave a straight edge on that side. And then for this bead, same thing. You're just good and hot, keep the stick out short, try to flow up just to the straight edge of the bevel so that you have a nice straight edge to guide you for your cover pass. Now, as you can see here, the edge was melted just a little bit, so the edges aren't perfectly straight, but they're close enough. Just if you're wondering what I'm talking about here, it's this right here on the left-hand side here, how the puddle is consuming the straight edge there. So that makes these edges not quite perfectly straight, but again, they're close enough to follow to get a good cover pass. So then we're going to do a 2-bead cover pass now. And again, follow the WPS and make sure to let it cool off enough to be within the inner pass temperature requirements. And you're just trying to overlap that bevel by maybe a 1/16 of an inch. Doesn't even have to overlap it that much, but if you try to just meet it, you could leave a little bit, and that won't make it. Very last bead here. Again, just trying to overlap just what it takes. You want to go halfway over the previous bead, and don't get too far outside the bevel. Nice and steady. Keeping the stick out short. Incidentally, before you run these overhead passes, before each bead, make sure your nozzle is free of spatter. There's no little BBs on your contact tip, because that'll interfere with the feeding of the wire, and you don't want that. All right, that is done. Let's talk briefly about acceptance criteria that's in the American Welding Society D1.1, and this is pretty similar across the board no matter where you're taking a test. Weld reinforcement, that's the height of the weld, can't exceed 1/8 of an inch. That's 3.2 millimeters. Undercut has to be less than a 32nd of an inch, so that's roughly 0.8 millimeters. And that is the reason why you want to be slightly below flush like this just prior to the cover pass, because of that 1/8 of an inch height requirement on the reinforcement. That wraps it up. I would be very happy if you'd visit my online store at weldmonger.com.